Okay, I've just transferred that equation from the previous page, and I'm going to rewrite these equations as 10 over 10 minus Vx over 10. It's quite legal to write it like this. 10 divided by 10 minus Vx divided by 10 is the same as 10 minus Vx divided by 10. You'll see why I'm doing this. I'm not going to, I know that's 1, but I'm not going to actually make that 1 yet. You'll see why in a minute. 20 over 6 minus Vx over 6 equals Vx over 8. So now what I can do is, because I've got Vx terms and non-Vx terms, I'm going to move all the Vx terms to the right hand side and leave all the non-Vx terms on the left hand side. So I got 10 divided by 10 plus 20 divided by 6 equals Vx of 8 plus, because I've transposed it to the other side, Vx over 10 plus Vx over 6. And now I can actually take out a factor of Vx, because each of these on the right hand side has a Vx in them. So let's do that. I'm still going to leave this as a fraction. Plus 20 over 6 equals 1/8 plus 1/10 plus 1/6 Vx. Now, the reason I've done this is because I'm going to get a common denominator, and in this case, now the common denominator is 120. So what we say is, how many times does 10 go into 120? Well, the answer's 12, and there are 10 of them. So I've got 120 over 120. So as you can see, that's still 1, isn't it? How many times does 6 go into 120? And the answer is 20. But I've got 20 of them. So therefore, on the bottom I've got 120, on the top I've got 20 times 20. How many times does 8 go into 120? The answer is 15. I've got 1 of them. So I've got 15 over 120. How many times does 10 go into the 120? The answer is 12. And how many times does 6 go into 120? And the answer is 20. Okay, and all that's multiplied by Vx. Now, the reason I've done this is because every single term now is divided by 120. So I can actually just multiply through by 120, and all those 120s will disappear. So I've got 120 plus 400 is 520 on that side. And I've got 15 plus 12 plus 20, which is 47 Vx on the left hand side. So you can see that all of that has really cleaned that up. Therefore, Vx is equal to 520 divided by 47 volts. If we go back to the previous page, you can see that we've got 3 equations for I1. It's 10 minus Vx over 10. I2 is 20 minus Vx over 6. I3 is Vx over 8. But now, of course, we know what Vx is. So let me just put these down for you. Okay, you can see here what I've done is I have substituted Vx in each of these equations. Notice I haven't actually touched my calculator yet. Now is the time to get your calculator out and put these figures in. So let's do that. Okay, and now we get the 3 answers. You'll notice that this answer here is negative. Now, what that actually means is, when we selected the direction for I1, it was actually wrong. Because that answer's come out negative, I1 is actually going anti-clockwise. So it doesn't really matter if we get the direction wrong, because it will show up in the final answers. Now, the Kirchhoff current equation is still valid. So we found that I1 plus I2 oops, is equal to I3. So if we actually put these values in, minus 0.106 at plus 1.489, you should find that I3 equals 1.383. And if it does, you know you're correct. So it's a good check.